Hi, let's continue with our introduction to K-means clustering. So we already built this one from the first video. So this is a continue video for the introduction to K-means clustering. So in here we'll build the K-means clustering with optimization. So let's write some text for that. So K means with optimization, and now we'll define the distance. So but before that is we will write some theory. So in here is we will depend on the SkyB library. So which is a Python package that allows easy access to highly optimized versions of scientific calculations. So in here, we will implement Euclidean distance with CDIS, which is the functionally of which replicates the bare bones implementations of our distance matrix in a much more efficient case. So let's write some code for that. So first we will implement the implementing non-vectorized Euclidean distance. So in here we'll define this function which takes two arguments a and b. So in here we'll return the math.sqrt, and then we got math.bow. So in here we have is a0 minus b0 and then comma 2 plus in here is math.bow. So the power, so we got a1 minus b1. So we got a1 minus b1 and then comma 2. So let's run the cell. So I don't have any mistake, and that is good. And now we will implement. So implementing the optimize Euclidean distance. So in here we'll use the from SkyB dot spatio dot distance import cdisk, and we will store the value of x, or store values of x. So we have it x is 105 to 110. So let's run the cell. So we got an array like this. And then to calculate the distance, so we need to calculate distances and choose the index of the shortest distance as a cluster. So in here we have is for x in x here, and we use the count equal empty, and for c, so we need to create a variable to store the empty array. So in here we got c in centroid. So we have e counts. So we'll add on the, we will append, that means add the this with x comma c, and then now we will bring the counts, which is the calculated distance, comma. So in here we'll use a cluster membership, and then in here we'll have is nb dot nb dot admin, and then we will use the count s comma axis is equal to 0. So we need to move this one in here because we need to have, so after we appending the calculated distance, and then we bring the value of the shortest distance, which is a mean function in here. So let's run the cell. And now we'll define a new function. So in here we'll define the k underscore means. We got x comma k. So in here we will keep track of history, so you can see k means in action. So we have is centroid underscore history equal empty array, and then we got is labels underscore history equal empty array, and then we got run underscore index equal np dot random dot choice. So we open bracket the x dot shape, this will be 0 comma k, and in here we have is centroid equal x run underscore index, and then we will have is centroid history dot append the centroid, and now we have while true. So let's write some explanation in here. So Euclidean distances are calculated for each point relative to centroids, and then np dot arch mean returns the index location of the minimal distance which cluster a point is assigned to. So now we will write labels equal np dot arch min. So in here we have is see this x comma centroid comma axis equal to 1, and then we got is labels underscore history dot append. So we have is labels, and then we need to take mean of points within cluster to find new centroid. So in here we have is new underscore centroids equal to np dot array. So is the x labels equal to I dot mean axis is equal to 0 for I in range K. So X label so now we got is send choice underscore history dot append. We have is new underscore centroid. So if all centroids and new centroid do not change, k-means is complete, otherwise continue. So in here we have is if np dot on. So we have is centroids equal new underscore centroids. So we have is break, otherwise centroids equal new centroids, and then so new underscore centroid, and then we need to return centroids comma labels comma centroids underscore history comma labels underscore history. So I did make a pause and fix all the indentation. and make it more clear. So let's run this function, and we need to create a new function. So we need to for x comma y in history, and then in here we have to plot. So blt dot figure, and then we have a fixed size equal to 4 comma 3, and then we'll have is blt dot scatter. In here we have x open bracket is semicolon 0 comma, and then we got x1 comma c equal y comma s equal 50 comma c map is equal to top 20 to 20p. Top 20b, and then we got is blt dot scatter, which is the x 0 and then comma x comma 1, and then we got c equal red. So I did make a pause and write a zip function in here. So we need to have a history equal zip centers history, and we got a label history in here, and then we just for to plot a figure. So let's run the cell. So as you can see that we can see obviously on the cluster with the centroid in here. So let's write some explanation on that. So explanation. So in here, as you can see from the above image, k-means takes an iterative approach to refining optimal clusters based on distance. And then the algorithm start with random initialization, and depending on the complexity of the data, quickly find the separation that make the most sense. And that is all in this video. So I hope you enjoy it, and I will see you in the next video. So if you see this video is useful and you learn a lot, please press the like button and subscribe to my channel for more videos just like this, and I will see you in the next video.